Alright, now we're going to talk about even and odd functions, the symmetry of it. So right here, if you notice, we have an even function on the left side. It is symmetrical on the y-axis. Also notice that the x values change. So you got -2 and +2. And the y values stay the same. Alright. Odd functions are rotational about the origin, so you can rotate them around the origin. They're equal distance from the origin. Notice how this one goes up 5, this one goes down 5. Also notice that what changes, both the x and the y values change. What stays the same? Nothing. So they'll just be opposites. So the x is 3 on one side of the origin, then you'll have a point that's -3, so opposites of each other. 5 and -5, and the y values will be opposite of each other. So you see here, opposites. Describe the characteristics of the even function that you see on the graph. We call f an even function if f of x equals f of -x. So that means when you see that negative right there, that means the x sign is going to change. X sign changes and the y sign stays the same. Symmetry about the y-axis. Number 1 at point 1, 2 is -1, 2. A point on the graph also. Explain your reasoning. Alright, yes. We got 1, 2 and -1, 2. It's symmetrical about the origin. So we got 1, 2 and -1, 2. The x signs change. Yes, it's an even function. Describe the characteristic of an odd function that you can see on the graph. Both x and y values change, rotate about the origin. In number 2, at point 3, 3, and -3 is on the graph. Explain your reasoning. Alright. Right here we have 3, 3, and -3, 3, 3, 3, -3, -3. Both the x and the y values are opposite signs. So 3, -3, 3, and -3. So yes, it is an odd function because the sign of both the x and the y values are opposite. Function number 3 is a blank function because the type of function uses definition by observing it on the graph. So graph number 3 is an even function because it's symmetrical about the origin. And we got the points 1, 2, or excuse me, 1, 1, and -1, 1. The x value is the only thing that changes. The y value stays the same. Number 4 is an odd function. So, yes, it's an odd function. It's rotational about the origin. And we have point 1, 1, and point -1, -1. Both the x and the y value change. Alright. Describe function 5. Function 5 is symmetrical about the y-axis, so it's even. Number 6 is not rotational about the origin, doesn't go through the origin, nor does it cut through, it's symmetric about the y-axis, so it's neither. Suppose that f of x is an odd function, -2 and 8. So if I have -2, 8, you can make them opposite because we know it's -x and -y. So it'll change the sign of -2 will become +2. So we'll have minus a -2 and a -8. This makes it into 2, negative 8. Suppose f of x is an even function. 2, negative 7. So we know it's negative x and y. Right here we'll have negative 2 and 7. Last one. A function g is an odd function if negative 3 equals 4. Which points on the graph, which of the points lie on the graph of g? So it's an odd function, so both the x and the y have to change. So right here, this is the x value, this is the y value. So we know that it's negative 3 and 4. So they got to change their signs, negative x, negative y. So we know it should be positive 3, change the sign, negative 4. Okay, which statement is true about f of x equals 7? If I was to graph that line, it's x equals y equals 7. So remember f of x, same thing as y. Comes right through here. We know that all of my x values will be the same. So we'll have 1, 7, negative 1, 7. So the x values change and the y values stay the same. So function is even because f of negative x.